Okay, we are going to start our notes. 2.2 notes, slope from a table and linear versus nonlinear. Put our names. And it is currently second hour. Linear lines have a consistent rate of change or slope. So a consistent rate of change or a consistent slope. Slope is rise over run right. Which is your change in y. Over your change in x. To determine if your line is linear or if it's non-linear, or your graph, I should say, is linear or non-linear, you need to find the change in your y values and the change in your x values and make sure that they are consistent. If they are consistent, your table is a linear relationship. So from -1 to 0, what is our change?
Y's on top, I would do Y's first, because every time I used to always do X's first and I would forget. So since it's change in Y over change in X, let's look at our Y's first. Just so we get into how to do that. Because I think we'll be better at keeping them on top if we start with them.
Fair enough. So our change in y's, change from 5 to 3.
-2.
Change from 3 to 1.
-2.
And from 1 to -1.
-2.
And then we can do our x's now. So our change from -1 to 0. Change from 0 to 1. And from 1 to 2. So our slope is our y over our change in y over our change in x. So we have -2 over 1. Or -2. Is the change in our y values and the change in our x values consistent? Yes. So this is linear. For this next one, what is our change from 2 to 3? And our change from 3 to 5? And our change from 5 to 9? change from -1 to 0, 0 to 1, and 1 to 2. So our slope is change in y over change in x. So all of our different slopes here, that's our slope for this first set of pairs, of ordered pairs. Our second set is 2 over 1. And our last change is 4 over 1. Is that consistent? No. They do not equal each other. So if we don't have a consistent slope, we can't write a slope. There is no rise over run to write. So we don't have anything to write in our slope box for that one. But we do have to circle, is it linear or nonlinear? Nonlinear. All right, for this one, change from 1 to 3. From 3 to 5. And from 5 to 9. Our change from -5 to 0. Our change from 0 to 5. And our change from 5 to 15. At first glance, do we think this is linear or nonlinear? Nonlinear. But our change for these first two is 2 over 5. And then our change for this last one, it's 4 over 10, but yes. You guys, I write way too big. I'm going to rewrite that so that you understand what I'm trying to say. So now do we think this is linear or nonlinear? Linear. And what is my slope? 2 over 5. Change from 7 to 6. -1, yep. Change from 6 to 5. And change from 5 to 3. Change from 1 to 2. From 2 to 3. And from 3 to 4. Non-linear, because we have -1 over 1 and -2 over 1, and those are not equal. So we are non-linear here. Okay, we have 2 on the back. For these, we need to graph. We need to plot our points. So I need to put a point at -3, 1. Am I going to go left or right? Left. Am I going to go up or down? Yep. So left 3, up 1. And then a point at 0, 3. Am I going to go left or right? I'm not going to go left or right. Am I going to go up or down? Up. 2, 6. I'm going to go right 2, up 6. And 5, 7. Right 5, up 7. Can you take your ruler and draw a straight line through all 4 of these points? No. What does that tell you? Nonlinear. You won't always be able to just tell based off of glancing, because the points may be so close to linear that you won't be able to tell the difference. So you always still want to count your change in y over your change in x. But this one we can tell very much nonlinear. All right, last one. I'm going to go right 1, down 2. Right 1. Right 1, up 2. And right 1, up 4. Can you take your ruler and draw a straight line through these? Does it have a slope though? No. Because we have 0 over 2. So we are linear, but our slope is undefined. Go ahead and glue those in to your notebooks on the page right after your 2.1 notes. Stop my